I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are serving you for last 15 years absolutely free videos on YouTube channel. In this video, we are going to discuss growth rate and decay rate with the help of three examples. Let me share with you the questions which we are getting into. So we'll try to understand how do we figure out whether an equation represents decay or a growth. Then we'll try to understand how do we find the growth factor and the growth rate from the given equation. So based on that, we have two examples right before you. Now before getting into the solution of these examples, let's try to understand what is growth rate and what is growth factor. How are they different? In general, an exponential equation can be written as y equals to ab to the power of x. So b is to the power of x. Or something like a equals to a0, 1 plus r to the power of n. Well, in this case, the initial amount is a0 or a. Both equations represent the same thing. So when we talk about such equations, the initial amount could be written as a, as in the first equation, or a0. Now, what is growth rate in these equations? Growth rate is not clearly mentioned in our first equation, but in the other one, growth rate is r, and normally it will be given in percent. We'll see how to find this out. How about the growth factor? Well, the growth factor is b, the term by which each consecutive number is multiplied in this sequence. You can say it is the ratio of consecutive terms. Or it could also be 1 plus r if the equation is given in the second form. Time intervals. Now, n is the total number of time after which we are trying to check the growth or the decay of the item. So the total time interval is n, and the final amount is given by the expression y or a. So I hope that is absolutely clear. And these are the two forms of exponential equation which you will normally see. Now let's look into each very carefully. So the first question here is, which of the following equations models exponential decay? Now, exponential decay really means that the factor with which you are multiplying is less than 1, right? So, exponential decay means if the equation is y equals to a, b to the power of n, in that case, b should be less than 1. And of course, b is always greater than 0, right? So, this is what we are looking into. Now, here clearly, this is not an exponential decay since it is 2. 0.5, 1.5 is not an exponential decay, but 0.85 is an exponential decay, right? Since 0.85 is less than 1 and greater than 0, correct? Part D is y equals to 3 by 2, 0.5, but the exponent is minus x. So I could also rewrite this as 3 by 2 times 0.5 can to the power of minus 1 will really mean 0.5 is half, right? So let me first write it as half to the power of minus x. But negative exponent really means that I'll flip it, right? So it will be written as 2 to the power of x. So this is not a decay, right? Not a decay. And therefore, option E is not correct. Only option C is correct in this particular case. You get the idea. So, looking at the equation, you can figure out whether it represents exponential decay or growth. Now, we need to figure out what is the growth factor and what is the growth rate. Question number 2 here is, in the exponential model, a equals to 80, 1 plus 0.5 to the power of n. Find the growth factor. Now, growth factor is the term by which you multiply, right? So, you're multiplying the initial amount 80 by 1 plus 0.5 each time. That is what it means when I write to the power of n. So, clearly, the growth factor here is 1 plus 0.5. So, that is the growth factor, which is equal to 1.5. And therefore, the growth factor is 1.5. Is that clear to you? Right. Now, find the growth rate. Now, growth rate, as I said, is given as percent, right? So it is R percent. Now, rate is 0.5. So in this case, 0.5 can be written as what? Well, if you write it as a percent, this could be written as 50%, correct? This can be written as 50%. Since converting to percent will mean 0.5 times 100, right? So that will be in percent, right? So this is equal to 50%. So the growth rate is 50%. So I hope this is absolutely clear, right? So we have found that the growth rate in this particular case is 50%, correct? Let's take the next example, which is of the other form of the exponential equation, which you normally see. In the exponential model, m equals to 100 times 0.85 to the power of n. Find the decay factor. Well, since 0.85 is less than 1, it represents exponential decay. So the graph will be kind of like this, right? Decreasing every time. So decay factor you can find by what number is 100 being multiplied. So clearly the decay factor is what? Decay factor is 0.85, right? So let me write decay factor. It is 0.85. So every time you multiply by 0.85, so it is decreasing by that rate. Now, what is the decay rate? To get the decay rate, we should split 0.85 as 1 minus what, correct? So then you get decay rate. So what I'm trying to say is 1 plus r should be equal to 0.85. This is how we can find r. So r is equal to 0.85 minus 1, which is negative 0.15. Negative indicates decay, right? It is decreasing by this amount. So in percent, so convert that to percent. So convert to percent. So we get minus 0.15 times 100. So it becomes 15%. Minus means decay. Therefore, we can write down that the decay rate is 15%, right? So that is how we will find the decay rate from the given equation. So I hope you understand now. Given the equation in these two forms, how do we find the decay rate or decay factor and growth rate and growth factor? Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.